Now in this video, I want to talk about the surface area of prisms. Last video and last lot of exercises, we started talking about just area, plane shapes, two-dimensional figures. Now we're going to start doing our work based on areas of three-dimensional figures. A cube, for example. So we can't talk about the area of a cube because area refers to a flat two-dimensional figure. This shape has got 6 flat two-dimensional figures, all these 6 faces. So when we talk about, we don't necessarily do the area of a cube, we do the surface area of the cube, the area of all the surfaces. Now, I know a lot of people in maths are always saying, "Oh, Mr. O'Sullivan, what's the formula for this? What's the formula for that?" Seriously, when it comes to things like this, there's very, very few formulas you need to know. Just work it out by common sense most of the time. So like for this one, each of these faces is exactly the same size. Work out the area of one face, times it by 6. Other shapes. Now, it's cuboid in shape, but it's actually not a cube. It's a rectangular based prism, or a rectangular prism. Now a prism, the definition of a prism is a solid figure that has a constant cross-sectional area. Like the front here, that shape, that rectangle, is exactly the same as the rectangle at the back. And if I were to make vertical slices, the shape that gets exposed all the time is the same rectangle. So the area at the front continues all the way through to the back, a constant cross-sectional area. Obviously you can go on a couple of different planes, 3 different planes. With this one, it's a prism. So for this one, that front face has exactly the same area as that back face, so work out the area of 1, and then double it. That side face is exactly the same area as that side face, so work out the area of 1, and double it, top, bottom. Just common sense, no formulas needed. Now, one's like this. That is a hexagonal prism. You may be given enough information to work out the area of that shape, you may not. The question will give you enough information, either tell you the area or enough information to work it out. One's like this, not a prism. This is a pyramid. Different scenario altogether. We're not going to be dealing with those just yet. Now, the only prism that you really need to know a formula for is this one, a cylinder. So just like that. 2 circular bits and then a body part. If I were to roll this out, so I took this body part and I rolled it out like that, it produces a rectangle. This circle here goes there, this circle at the top goes there. I'm able to generate a formula now for the surface area of this cylinder, because all this folds up to make the situation. Now, for this, you need the area of these circles. Well, we know the circle has a certain radius, so for one circle, a little early there, I'll put that 2 in a moment. For one circle, pi r squared is the area of the circle. We of course have 2 circles, so we're going to do 2 pi r squared. That generates that. Now, for this body part, it's just a rectangle. It's going to be the length times the width. Well, in your question, you're going to be given the height of the cylinder. When we say height, we mean the distance between these 2 constant cross sections. So the cylinder is held that way, that's its height. The cylinder could be held that way, we're still talking height that direction. The distance between the 2 constant cross sections. Obviously, that's height. Now, this side here, can you see that this side here wraps around this circle? So if I fold it all up, this side here will wrap around that circle. So in other words, the length of that line is the same as the length of that line. Well, that's the circumference of a circle. So the circumference of a circle is 2 pi r. So that gives that line will wrap around that circle. And of course, area of rectangle is going to be that times that, so 2 pi r h. So the only formula you need to know, you need to memorise, is the surface area of a cylinder, 2 pi r squared plus 2 pi r h. Now, in your questions, we will always assume always assume that the cylinder has a top, there it is, and it has a bottom, there it is. Unless the question specifically tells you there is no top, there is no bottom, or there's something in the question that implies to you quite strongly that there is one of those is missing. For example, you might get a question where this might be a water tank, and you're asked to paint the outside of the tank. It's sitting on the ground, so you don't need to paint the circle that's on the ground. In that circumstance, you would have to modify this formula, because the 2 pi r squared is the area of both the circles. If the question makes it clear that one of the circles is not involved, instead of 2 pi r squared, you are going to have to modify it to 1 lot of pi r squared. There's lots of other modifications that the question could imply, but we always start with that and then modify it depending on what the question asks for. And so that'll give you some practice on those style of questions. Now, I went through my phone the other day. I have a lot of German friends and a lot of German relatives. I've gone through and deleted all those German names out of my phone. So I can now say that my phone is now officially hands-free.